All right, good morning, I guess. We are talking about good afternoon, good evening, whenever you're watching this. That's the beauty of the videos. You can watch them whenever you want. Let's see. So we're talking about systems of equations, and 4.2, section 4.2 talks about the substitution method. So if you take a look at the graphing method that we did in 4.1, you can see that it kind of lends itself to maybe some errors only because of a graphing possibility that you've made an error, or not so pretty graphing. Your hand might slip when you're graphing something, and especially if you're graphing some lines that might be a little bit off the grid pattern, then you're really kind of guessing if they don't fall right on the if the lines and the intersection especially doesn't fall right on the grid pattern. You kind of run into a situation where it's not quite exact, and you can't find exactly what the answer is. So with the substitution method, actually this one 4.2 and 4.3, we're going to use some methods that might be a little more, in fact will be a little more accurate as far as exactly finding the answer. So in 4.2, we're talking about the system of equations, or solving a system of equations using the substitution method. So we're going to substitute a couple things in. So let's go down. We're going to do example 1, example 2, and another video showing what no solution looks like, and showing what the same line looks like in next videos. But for right now, we're just talking about the first example. All right, so here's kind of a, let's see. Talked about the impreciseness of graphing. We can use substitution, though, in this method to kind of give us more precise answers. And here's kind of the executive summary that I kind of borrowed from the book and kind of summarized myself. And if you need to put this down in terms of what steps do I do first, it'll start coming to you, I think, more easily and more readily, I guess, when we're using it. But essentially, hang on one second. Essentially what we have to do is take our system of equations, number one, write one of the equations, either one, as x equals this. In other words, solve for x for our first equation. Solve for x equals something. Everything else is going to go on the other side, but 1x is going to be on the left side of the equation. Everything else is on the right side. And then you take whatever you've underlined here, this that you've solved for, this thing over here, you put that instead of x into the other equation. And what you'll have left is, because you'll have over here something, 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 and y, something, something, something maybe. And all you'll have in that second equation, when you substitute in this y for x, you'll eliminate the x in the second equation, and you'll just solve for y. So then you'll get something like y equals some number. And you'll have half of your solution done. And now you take that y equals some number and you put that value of y into either original equation and then solve for x, and you get x equals something, some number. And then you'll be done. You'll have a solution. And then you can double check your solution, both original equations, and you could probably double check by graphing both lines, but I would say as long as we double check here, we're going to be okay. And keep in mind that you don't have to solve for x right away. You can solve for y. If y is just by itself, you can solve for y. Solve up here for y equals something. Substitute in for here for y equals whatever into that second equation, and then solve for x in the second equation. You get an x equals some number, and then you solve for y in the second step. So let's try to make this a little clearer and say, well, let's go and do an example. So here's my instructions. Solve this system. We've got a system of equations here. Here's one equation A. Here's one equation B. In other words, solve means find that x, y ordered pair using the substitution method. All right, well, the first step we do is, well, this one A, equation A, is already substituted in, or sorry, is already solved for x. X equals 2y minus 3. Well, shoot, this system lends itself really well for using the substitution method. So you take that 2y minus 3 and substitute in right there into that second equation where the x is. And you write negative 4. There should be a negative 4 there. That's a negative 4. Negative 4 times, instead of calling it x, we'll call it 2y minus 3. Instead of calling it x, we'll call it 2y minus 3. And then you rewrite everything else that you got. Plus 3y equals 2, plus 3y equals 2. And all of a sudden now, in this equation here, We've got one equation in one unknown. We've got a y on the left side, we've got a y on the left side, we've got no x's anymore, so we can just simply solve for y. And what we do is we distribute that -4. And the intermediate step would be -4 times 2y is -8y. -4 times -3, negative times a negative is a positive, is 12. 3 times 4 is 12, plus 3y equals 2. And then the next step is, from down here, we combine like terms. -8y plus 3y is -5y, plus 12 equals 2. Subtract, and now we're just solving basically a two-step equation where you've got a y term and some numbers. We move the 12 over to the right by subtracting 12 on each side. We say -5y equals, these go away. 2 minus 12 is -10. Divide by -5 because we want y just by itself. Y equals -10 divided by -5 is +2. And there is half of our answer. And now we take that y equals -2, plug it back up into either one of these equations. I would guess we could use equation A because it's already kind of solved for x. And we could say, all right, well, x equals 2y minus 3 is my original equation. I recommend writing down that original equation just so you're not doing two steps at once. And now substitute in y equals 2 right there. Now we can say x equals 2 times 2. Did I say -2? It should be +2. 2 times 2 minus 3. X equals 4 minus 3. X equals 4 minus 3. 1. Done. And now we can double check all of our work. We can say that 1 equals 2 times 2 is 4 minus 3. 1 equals 4 minus 3. 1. That checks out. And double check by putting in x and y right up in here as well. I can do a double check and say that 4x, hang on a second, let's see if I can get -4x plus 3y. I'm rewriting equation B right down here to double check. Equals 2, and we're going to substitute in 1 and 2. -4 times x is 1, plus 3 times y is 2, equals 2 with a question mark. -4 plus 6 equals with a question mark 2. -4 plus 6 is 2 equals 2. Sure enough, it checks out. It checked out in the green A equation as well, so that is a solution. So we could write 1, 2 as our solution, and there's our solution, and we're done.